Welcome back. This is a follow-up for the previous video in which we went over whole numbers, natural numbers, prime numbers, and composite numbers. So let's review before we go into a few problems. So we know that natural numbers, known as counting numbers, or sometimes referred as counting numbers, are numbers starting from 1, 2, 3, 4, and goes on and on and on. We then go ahead and refer to whole numbers, and whole numbers includes the natural numbers and zero. So that would be, we include zero. So then we have the natural numbers, which are counting numbers. And that goes on and on and on. So prime numbers, now before we go to prime numbers, let's talk about product and factors. So when two numbers are multiplied together, say 6 times 7, we get the product 42. So when two numbers are multiplied, the result is called the product. We have the product right there. And the number being multiplied, or the numbers being multiplied, are called the factors. So that would be 7 and 6 are factors of 42. So now we can take a look at prime numbers. And prime numbers are natural numbers. As we said earlier, we refer to those as counting numbers. And those numbers greater than 1. So prime numbers are numbers greater than 1, counting numbers greater than 1, whose only factors are 1 and itself. So notice that earlier, our factors of 42 was not just, we didn't use 1, so we could say 1 and 42 is equal to 42. And that means if that was the case, which it's not, if that was the case, we could say that 42 is a prime number because it would have a factor of 1 and itself, which is 42. So prime numbers are numbers that are greater than 1, whose only factors are 1 in itself. Greater than 1, so we'd have to start from 2, 2, 3, 5, 7, 11, 13, 17, and 19. Goes on and on and on. So then we look at composite numbers. So composite numbers are natural numbers greater than 1. Again, it has to be greater than 1. That is not a prime number. So we know that natural numbers, we refer to those as counting numbers. And we want a number that is greater than 1. So that could be a prime number. However, though, it's not a prime number. So therefore, it has to have a factor other than 1 and itself. In this case, composite numbers would be greater than 1. So it would be 2 is not a composite number because that number only has 1 and itself as a factor. So we go 4, we go 9, 25, 39, 62, 76, and it goes on and on and on. So notice that 4 is greater than 2. Well, it has to be greater than 1, so 4 is greater than 1. 4 has 2 as a factor. So that means it doesn't only have 1 and itself as a factor. So that is classified as a composite number. So another thing is prime factorization. So every composite number can be written as a product of prime numbers. And this unique product is called the prime factorization. So if we take, say for instance, a number 60. So a number 60, which is a composite number. We could have included 60 in the composite number we're writing out. However, we just wrote out several numbers off the top of the head, which we classify as composite number right here. So 60 is a composite number. And we can write 60 as prime factors. So we know that 2 times 2 times 3 times 5. And these prime factors of 60. Normally we use the tree, the factor tree. So we'd put 2 times 30, 60. Bring down our 2. And we'd go 2 times 15. Well, it should be 2. 2 times 15 is 30. We bring down our 2. Bring down our 2. And then we'd go, can't use a 2 again, which is the smallest prime factor. Now we have to use 3. And 3 times 5 is 15. So these are the prime factors of the composite number 60. And basically that's our review for the previous video, which I'll link in the description. So let's go ahead and tackle these problems. So the first number, well, let's read that. So classify the number as prime, composite, or neither. So either it's a prime number or a composite number, or it's not. And if the number is composite, write it as a product of prime numbers. Okay, let's do that. So for 29, we have 1 times 29 is 29. We can't use 2 and we can't use 3. There's no other factor of 29. So we can say that A, 29, remember a prime number is a number that is greater than 1 and has a factor of 1 and itself. 29. So we see that 29 has a factor of 1 and itself. So therefore this is a prime number. B. So 225. So by observation, the number 225, we see that 5 can be a factor. So we can see 5 can be divided into 225 even, completely, without leaving any remainder. So we know that 5 is a factor of 225. However, let's see if we can find a smaller number, because we have to use the smallest to the largest. So we want to find a small number. So let's try 2. 2 cannot be divided into 225 completely. So we're going to skip that one. 3 can be divided. So 225, let's use the factor tree method. 225. So the smallest factor of 225, prime factor of the composite number 225 is 3. And that gives 75. So again, we bring down the 3. And we see that 2 cannot be going to 75 completely, but 3 can be can go into, or 3 can be divided into 75 completely. So we use another 3. And 3 to 75 is 25. So we want to factor completely. So we see 25, 2. No, we can't use 2, can't use 3, can't use 4. However, we can use 5. So we bring that down. 5 is the smallest, and 5 times 5 is 25. So here we see that 225, you can write it either way, has the prime factors 3, 3, 5, 5. And that's a composite number. And always, here we have the prime factors, and every composite number can be written as a product of prime numbers. So if you take a look, each of these numbers are prime numbers. Why? 3 has the prime factors 1 and itself. 5 has a prime factor of 1 and itself, and these numbers are greater than 1. So they're prime numbers. So we go ahead and do C. 49. We think about the smallest number that can divide completely into 49. And if we start from 2, 3, 4, 5, we see all those don't work. 6 don't work. However, 7 does. So 49 divided by 7 gives 7. So the prime factors of 49, 7, and 7. Therefore, 49 is a composite number. Why? it's greater than 1, and it has a prime factor. It has a prime factor that is different from 1 in itself, which is 7. So we classify that as a composite number. D is 101. And if you try a number from 2 up to 100, it doesn't work. So this number has a prime factor of 1 and itself, which this number is greater than 1, and it has a prime factor of 1 and itself. Thus, this number is a prime number. So let's take a look at the other problem. So the next problem asks us to write the composite numbers as a product of prime numbers. First one is a little bit easy. See that A is equal to 6. So we know that 6 can be divided by 2. So if we use the tree method, 2 times 3. So 2 times 3 is equal to 6. We see that this number has a prime factor different from 1 in itself, and the number is greater than 1. So it's a composite number. However, we don't have to look at that anymore because they already stated, write the composite number as a product of prime numbers. We just have to make sure that the factors are prime numbers. So we have to simplify that until we get all prime numbers as factors of the composite number. B. 8 is a little bit simple as well. So 8, we start with the smallest prime number, which is 2. We get 4. Bring down our 2. Smallest prime number into 4 is 2. So the prime factorization for 8 is 2, 2, 2. We go ahead and we do C. So C is 229. Again, we look at the smallest prime factor number that can divide it into the composite number, and we get 2, and that will give us 147. We bring down our 2. We see that 2 is not the smallest anymore. 2 does not work here, so we try 3, and 3 works. So therefore we get 49. We bring down our 2. As you remember, we did 49. In 49, where's 49? Did we? Okay, here, so we did 49. C was actually 149. But anyway, let's leave it at that. 149. So we're going to act like we did 49. So 49, bring down our 3. So we get 7 times 7, 449. Thus, we see that this one is equal to 3. There's 3 for this one right here. So we have the prime factors of 2 and 3 and 7 and 7, which that is equal to 229. Let's go back up here and take a look at that. So if it was 149, which it is, C is 149, that would be a prime number. It has a factor of 1 in itself, and it's greater than 1. Let's say that's a prime number. So we go to D, which is 32. (32) is fun. We see that 2 is the smallest that can be divided into 32. Bring down our 2. And we see 2 can go into 16 as well. That gives 8. Bring down our 2. 2 can also go into 8. We bring down our 2, bring down our 2, bring down our, well, 2 can go into 4, and then we bring down our 2. So we see that 32 is equal to 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5. And that is the product of prime numbers for the composite number 32. So again, going over these problems, we know that natural numbers are sometimes referred as counting numbers, and those are listed here. Whole numbers are natural numbers that includes a 0. So we have the 0 with the natural numbers. We have products and factors. When two numbers are multiplied together, we get the product, and we have the factors. Prime numbers are natural number greater than 1, whose only factor are 1 and itself. Composite numbers are natural numbers greater than 1 that is not a prime number, and there are infinitely many composite numbers. So that's it for today's video. See you in the next one. Bye.